Imagine deploying a global app that syncs user data across continents in real time. Now imagine the chaos when updates collide. Welcome to the world of multi-leader replication conflicts. Multi-leader replication involves several nodes, leaders, accepting write operations and replicating these changes to each other. Conflicts arise when two nodes modify the same data independently. Conflicts are resolved using strategies like last writer wins, version vectors, or custom application logic, each with trade-offs in terms of consistency, latency, and operational complexity. Let's examine version vectors, a mechanism that tracks the version history of data across nodes. Unlike last writer wins, which simply favors the latest update, version vectors enable a detailed conflict resolution strategy that considers the history of changes. Implementing version vectors requires additional metadata storage and processing logic to compare vector entries and resolve conflicts. This complexity is a trade-off for achieving eventual consistency and maintaining a more comprehensive history of data changes. Choosing a conflict resolution strategy involves trade-offs. Last writer wins simplifies resolution but can lead to data loss. Version vectors offer detailed history tracking at the cost of increased storage and computational overhead. Netflix uses multi-leader replication for its global user base, optimizing for availability over immediate consistency. Uber, focusing on accurate ride information, might prioritize conflict avoidance techniques or stricter consistency models. Mastering multi-leader replication conflicts is about balancing consistency, latency, and operational complexity. Understanding these trade-offs and choosing the right strategy is crucial for designing resilient distributed systems.